distance, displacement. Don't let me waste time about this one. So
Yes.
talk about okay. Don't let me waste time about this one. The velocity, the normal one that everybody knows per unit time. Or if you write another formula, you are covered. You have to define velocity. If you write it as well, distance over time, displacement over time, speed over time, distance over time, it's okay. It's the same, it's accepted. So velocity change. Now this is where the journey begins. If you understand the concept of graph, then you won't find it difficult because it has to do with graph. You have to interpret, you must be able to sketch. You may be given a distance time graph, then you have from that graph you have to sketch velocity time graph. So that's just that's the understanding about this. That's what it's all about.
Yes, sir.
Now, distance time graph, we have different types of graph. This one is still directly. When you have distance against time, of course, the slope is expected to give you the speed. So the gradient will give you speed. So now, if you are to interpret graph, you can interpret graph in terms of two things. In terms of what two plots, what is on vertical axis here, and at the same time, in terms of the gradient. No,
Yes.
you have to understand the question. The question describing, are you to talk in terms of gradient or in terms of the graph that you plotted? Or if the question is not even is even silent about any, so you have to incorporate the two. So what happens in this kind of system? When you have this kind of graph, we say the distance, the gradient is constant because it's a constant. A straight line like this means a constant gradient. So it means because distance is increasing linearly. Yeah, distance is increasing linearly as you move from here. Distance is increasing linearly at equal rate, but the gradient is the same. It's the same at any point. Gradient is the same. So the gradient is constant, meaning that the speed is constant. So this means this one represents a constant speed. Distance increasing linearly. Is that taken?
Yes, sir.
Okay, fine. Now moving on to this one too. When you say a straight horizontal line, it means there's no gradient. So many gradient is zero. It means speed is zero. So there's no speed. So understand this type. The gradient is zero, meaning distance is constant. Gradient is zero. So that was mean. Now this is another one. Distance increase at not uniform rates. Yeah. This is an increasing graph. Gradient is increasing. In this case, it's increasing. This is an increasing gradient graph. So you should understand when the graph increases. So what does it mean by it? Okay, let me even just put something here. How do I even know it increases? If you are to draw, I used to do this way. Draw a line to this way. Let's say draw a line to any point. So if you go and look at this angle here. Look at this angle. As you are going higher, what happens? It will increase. It increases. Yeah. So it's increasing. So that one will create increases. So that's just a way of putting in that way. It's a graph in which gradient increases.
Yes, sir.
So that means the speed increases.
Yes, sir.
What do you say?
Yes, sir.
What
No,
is
I'm
it?
saying yes.
Okay. Now, distance increases, now your speed increases, and there is what? Yes, it accelerates. So there's another one I can also draw here. Let me draw similar to this. Let me draw it here. Yeah, because I don't think that we have, if I have this graph, this, if it's like this, uh if it's so, look at the from here to look at the from here to there. This is distance against time. So in this case, acceleration is constant. So you have to sketch it at your hand. It's constant. But this one means it accelerates. This one is a constant what? Acceleration. So take note. So when it's far away from the vertical axis, it's like this, it accelerates. This one, it does not accelerate. Acceleration is constant, no acceleration. So take note of that.
So you're
Is
saying
that
that
taken?
when the curve is closer to the
Yeah. 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 It's closer. It does not accelerate. It's a constant. If it is distant against distant time graph, so that's how to differentiate that.
okay.
Now, the speed. Now, Distance, this one means when you have, okay, do I not draw a decreasing, okay, I draw it here, a decreasing graph. When you have, come and give me, come, give me 1 minute. Now, when you have this kind of graph, from this particular equation you have, if you have, you will see the paper one now that the graph will be giving, will be drawn, will be given. So we are looking for which one is corresponding to whatever you're asked to do. Now, from this particular one, you can see that very large t score, meaning that a over 2 giving what gradient. If you follow this way, that's the gradient. Now, if you have it this kind of graph, so if you have to scale the graph, this is good. But if you want to scale a graph of x against t, there's no t. We only have t squared. So there is no t here. So if you have a d square, this is a quadratic. Let me put it, it's a quadratic equation. Fine. So it's going to be like
Yes.
this. But because I don't need the second one, I do second one, it's going to be the other way around, but we don't need that one. So this is the graph x against t from this particular formula. For ordinary against t square. So this is the graph. So take note of the two. So take note of the difference between the two. And can also be extended to something like this. I can extend it to something like this. So I can extend it to something like this. For instance, if I have, let's say formula that's, let's now say x is something raised to power, let's say a over 2, then 2 raised to power 4 now. That's what I have. And I want to plot x against t square. So that will represent, no, against t4. It will be the same thing as this one. If I want to plot ordinary x against t squared, it will be like this. Yeah, because this is going to give me half. Again, half of this one, it will be like this. Because there is no t square in the formula here. So it's the same thing. So when you have ordinary t square, you see, when it's half of it now, you divide that, you remove one thing, you leave this. The same thing, if you have power 4, it will be like this. If you have now, let's say you are changing, you have to plot t against 2 now, x raised to power 3 last to what t square. That will be t square here. So it's going to be the same thing as this graph. So in case, so just know that facts.
Say, wait, say. You said if it's t squared, right?
Yeah, if you are plotting the, for instance, if you have p, maybe p is equal to x power 4. So you are
Yes.
plotting p against 4. P against power 4 will be like this because it's
Yes.
direct. But if you are
Yes.
plotting p against x square, it will be like this.
Oh, okay.
It will be like this as well.
Okay.
So it will be like that. I don't want to tamper with this. Okay. You can also have a decreasing graph. I didn't draw down here, so I think I draw it here. Something the same thing. So you can have a decreasing graph. A decreasing graph is going to be like this. Instead of say this is an increasing graph, it's increasing slope. So this is a decreasing slope. Uh-huh. So that will be decreasing slope. So this is a decreasing slope. Increasing, this is decreasing. It can be distant against t. So you can add that on to your this. So that means gradient is decreasing. That is speed decreases. In
Yes.
fact, it can decrease to zero if it now becomes straight here. Yeah. If it becomes straight now, look at it, it looks like this one now. So it looks like this one. So from here upward, it becomes 0. So it looks like this one. So you can see the difference now.
Yes, sir.
Okay. displaying time graph in the same format, but what's the difference? What changes here is the gradient. The name of the gradient is different. So here now it gives you velocity. The gradient
Yes.
gives you velocity. So that what I think that was where I even start from. So okay, now about to find it gives you, so that means there is no velocity. Velocity is constant at zero because gradient is zero. Distance is
Mm-hmm.
displacement is constant. Constant displacement zero velocity. So you get the same thing here. So it's the same thing here. The only thing different is the name of the gradient. Okay. So
Yes.
you can see velocity decreases. Okay. I draw this one decreases. Fine. So non-linear, it decreases. So you can talk of in terms of the displacement here. You can say, okay, in terms of displacement is increasing. Displacement is increasing, but not at linear rates. But the gradient, which is the velocity, is decreasing. So you have
So
to
if I were
understand
to
which one.
mention both of those points, would I get 2 marks,
Is that
or would they see it as just one thing?
uh, is so it depends on what the question I ask you state and explain. Maybe the what happens to distance or displacement or the velocity. Or the question just say comment on the graph. If you have to comment on the graph, you comment on both what to plot and the gradient. Uh-huh. But if the question is specific, what was the effect of this, or what can you say about the velocity of this? So you have to talk in terms of velocity. So please describe the graph here. So you have to discuss everything, the distance, the displacement, and the velocity together. So in this case now, if I'm to discuss the graph now, I will talk in terms of I will talk in terms of the distance displacement. I will say displacement increasing displacement, but not at linear rate. And the other one, the velocity decreases. In fact, if it becomes straight after this one, so let's say it becomes now straight, so it decreases to what? To zero. Are we together?
Yes, sir.
Okay, fine. So good to go. So velocity, okay, time graph velocity, okay, okay. I try I won't draw the same one. Velocity time graph now. What will be the slope? Acceleration. So it will follow the same thing. So in this case, velocity decreases to zero. In this case, you can see now from A to B. I think I put it here. So objects enter terminal velocity. This is also a graph for an object dropped through air or inside liquid.
Yes, sir.
Take note it at your end. So it's also a graph when an object is dropped through air or in a liquid. So there will be air resistance or drag force. In terms of in air, we talk of air resistance. In liquid, we call it drag force. So we call it drag force. Now, then I still want to add something to. Okay, maybe at the end of the day. Okay, let me even put it now. And for this one, it decreases and becomes zero from between here and B. So the object enter terminal velocity. So at terminal velocity, there's no what? Acceleration. There's no resultant force. Objects. Uh, okay, we still explain this one better. I know that where I'm going now. Under kinematics, no, dynamics. Yeah, it's that we call it a skydiver. It's in my note. So I think I put through under a skydiver. Yeah, was enough for you. Okay, fine. Now, look at this one. So if you throw an object upwards, and an object is thrown vertically upward and vertically down. When it's going vertically upward, that's from here. This is the work. So the area of this graph represents the distance covered. The area of this point represents distance covered when it's going up. When it's coming down, the area of this also represents distance covered when it's coming down. So the idea when an object is going up and come down, maybe what you know is they used to draw it like this. I don't even know. Okay, going up, then come down. It's not correct. So this is the correct one. This is when it's going because at maximum height, the vertical component of the velocity is zero. Why did I say vertical component? Because what you guys know or what you know, not even in fact, it is even what I yes, what majorly students know is that velocity is zero at maximum height. No, not all. It's only vertical component. Because velocity under vertical mode is divided is we have two types, vertical and horizontal component. It is only the vertical component that equal to zero at maximum height. The horizontal component is not zero. Therefore, under projectile, some question will ask you to calculate the velocity at maximum height. Are you listening to me?
Yes, sir.
You calculating the velocity at the maximum height means they're asking you to calculate horizontal component. Why? Because there is no what vertical component at maximum height. Is it making sense?
Sir, can you please go by it again?
Okay. Let me say, okay, wait. It's kinematics now. It should be here. Let me follow that. Then let me
That
see.
there's no vertical
I mean, no.
component at maximum height.
Okay, wait, don't worry. It's here. I have in my notes. So when I get there, I'll explain it better. So I
Oh,
have that point I have that point inside the notes. So when I get there, so let me leave that here. So at this t here means that's the time when the object gets to maximum height. So at that time, whatever value, when v is zero here, so you have v to
yes.
be zero in this point, fine. So that's the time when the object gets to the maximum height. So vertical. So if you read it with what I explained, read it well explanation. Vertical, vertically up and vertically down, fine. So at time t is equal to t1, the object gets to what maximum height. Fine, I've said so. Now you have another, let's say you have another graph. Fine. This graph, this graph one and two, they are the same thing, meaning the same thing. So you must be able to translate this to this. You must be able to move from, you must be able to move from displacement time graph to velocity time graph and also to acceleration time graph. Because you see that's where it's going to be in paper one multiple choice. You might be given the velocity time graph, and now say which one represents the displacement time graph. You must be able to move from displacement. Let me say, you must be able to move from displacement as x to velocity and to acceleration. At the same thing backward like this. You must be able to move backward this way. Fine. You must have this idea. Let's look at it now. What happened to the slope? What about velocity against time graph? What was the name of the gradient? Velocity time graph. What was the name of the gradient? Velocity
The
time graph.
gradient was. Hey, that's
It's
Sir,
what?
sir, may you please come again?
No. When you have velocity under this graph now, velocity time graph, velocity against
Oh, it's
time graph.
acceleration.
What,
The
what was
gradient
the
is
name of what was the name of that gradient? What do we call it?
acceleration.
Thank you. So now look at this now. What happens to the gradient? Is it constant or increasing or decreasing?
It's
Or zero?
constant. So that
Thank
acceleration
you.
and
That means A
velocity is
is constant. Constant. See the way I translate it. That means A is constant. Can you see now? This is a constant
yes,
graph. Have you seen the way I draw it? A is constant. So when you have this kind of graph, it's able to move back from here to this. You must be able to draw this. You must be able
yes,
to draw this. Now, at
yes.
the same time, velocity is constant now. How do I draw? How can I draw it under displacement time graph? The velocity displacement time graph.
So
Velocity
you're
is a
saying velocity
constant.
is
Which is
constant for that first graph. Is it not
yes.
increasing?
If oh, sorry, not constant. It's increasing linearly rather. It's increasing
Yes,
linearly. So how will I draw it? Yeah, that's increasing linearly. Velocity is increasing linearly. That is slope is increasing. The slope is
yes,
increasing. So it's going to be increasing slope. It will be this. Uh, so the slope is increasing. So it will be this. Yeah, it will be this. So that this many time graph, it will be this. So this, they are the same. They mean the same thing. So that's the idea.
yes.
Must be able to translate like that. So that is the idea. So these are the things I explain better in class. Everything might not be inside the notes like that, at least to some extent. No. So time graph is constant, so is constant, fine. Area under the velocity time graph. So I won't waste time. You should understand this. Area represent what the distance, the displacement. Area under the graph represent the displacement. So that depends on the nature of the graph. So look at this one now. Gradient of OA is called what? Acceleration. What do we call AB is
Yes.
a constant velocity. Then gradient of BC deceleration, fine. Displacement is what? Area under the graph. So that's a total area of the graph. So if I have to calculate, you can use trapezium or you can use triangle plus rectangle plus triangle. Add up together, it will give you
Yes.
that distance. Okay, fine.
Uh-huh.
Now,
Plus,
equation of uniformly accelerated. Fine. You must be able to prove this in case that for paper two, sir. So to prove equation of this, let me just quickly run through it. Equation of this. All right, please. Now, from the definition of velocity, change velocity over what? Over time. So if you put that, change velocity means final minus initial velocity. So if you do that over time, A is equal to the equation one. From the definition of average speed total distance over total time. So what's average speed? What's average in mathematics? You find the mean. You have two velocity. What's the average? Add up and you divide it by two. That's what I did here. It's equal to
yes.
this. So that gives you this fine. So what do you do now? Put V is equal to this in this. So anywhere you see V here, so the whole deal is V, then plus U, open the bracket, this and that, it will give you the same thing. Make T, so the formula from here, T. So when you make T, put it here as well. Put it in this particular one. So if you put it in there, so open the bracket, it different T square in mathematics, that will give all this, then from here. So that's the simple way of proving all these things. So just go the limit of all these things. So let me wait. Objects start from like zero, this and this. Most of that gravity, what's the difference? The only difference is that velocity equal to what? The same formula, but when in vertically upward, G is taken to be negative. So, and B final value is equal to zero, vertical component. So when it's coming down, vertically down, G is positive. Fine. Now,
So wait, wait,
how
wait,
do
wait.
you determine?
Say,
What is
please go back to that again. You said if it's downwards, it's positive.
where? This, where?
Yes.
This?
Vertically upwards, then it's negative.
Yeah, you can. That's the formula becomes negative. Yeah, it's because of G is negative. So when vertically upward, these are the formula you need. So G is negative. That's why it's negative. Yeah. So you are not going to negative is already in the formula. Don't change G to be negative again. So we apply that negative for G. So that's why I make the formula negative here. So value of G still remain as 9.81. So when it's vertically downward, it becomes plus. So the formula becomes what? Plus. And you can see age. So that's different. So when it's vertically down, and when an object is coming down, usually zero. That is equal to zero.
Yes.
Is equal to zero. Okay. This is an experiment to determine the value of G. How to determine the value of G? Experiment to determine the value of G. This level says we should teach students the experiment to determine what's the apparatus. We have electromagnets, we have light gates, electronic timer, meter, a steel bulb.
Mhm.
So, little bit sketch. You have a steel bulb. This is what represents my electromagnet. This is called a light gate. I use the light gate one, light gate two. So what happens? So as this object falls through this magnet, so when it strike this first light gate here, when it strike this particular, the first one here, the timer will start working, counting. So when the
Yes.
ball now strike the second one here, the timer will stop. So at that time, so you take note of the distance traveled by the ball. You record the time. You do it. So you do it. You change the distance again where the light gate is. You can move the light gate upward to obtain 6 different set of values. So after that, you get a table. So when you get the table, then you plot a graph. So when you plot a graph, the next is to calculate the gradient. So let me go through here. A steel body is relieved from rest from an electromagnet and or wait, okay. Falls under gravity. As it falls, it comma as it falls, double comma here. When you write, it passes through the light gate one, which switches on the electronic timer. Yeah, and passes through the light gate two, the light gates passes through the light gate, which okay, switch off. I am supposed to put light gate two here. So I supposed to put on light gate two here. The light gate two, since I've leveled down the sorry, let me quickly just adjust it right now. Yeah, of the time, the elevation time. The distance between the two light grades is measured using meter room. Then the timer is recorded by electronic the time. So the experiment is repeated by adjusting the position of the electronic timer to obtain the different values of height. So you get another, you adjust this, you can adjust the distance between this and this again to know where it's going to be. Run the experiment, take the measurement, take the time again. So after that,
They asked us to draw that setup.
you said
I'm saying, will they ever ask us to draw the setup?
to draw the setup.
Yes, sir. Like in the
No, they don't. No, they don't really ask for draw, but the question say we have to just explain. But Adam, wait, but the Kemi used to say you may draw dragon if you wish. That's their language. You
oh
may. That's the
yes,
language, yeah. They used to say you may if you wish. That's what they used to put it. You may draw dragon if you wish. But it's not something difficult. You can also draw it. That's something. I quickly sketch. You should even use to it because when you are doing A2 in P5, you have to sketch, you have to draw. So
okay.
now from here, take time. This got to for coming down, you got to zero. You have the plot, a graph of H against T square. So the gradient will give you G over 2. So find the gradient. Gradient is given like this, G over 2. So G will multiply by what? Gradient multiply by 2. That will give you value of G. So that's how to
Yes, sir.
calculate, determine.
Can
What was
you please explain that again?
plot from here? Just plot the graph. You have set of value of age.
Yes.
Like
Yes.
you have done this 6 times. You get. You
Okay,
also have the
gradient.
another one. And plot the
Yes.
graph. When you plot the graph, calculate the gradient of the graph. So
Yes.
that will be the gradient
Mm-hmm.
age against this. So
Yes.
gradient means delta H over delta T square. So what is the gradient? Gradient is G over 2 from here. If you look at it, if you plot, when you have this, that will give you A over G over 2 and T square. So if you are plotting this against this, so that should be gradient. G over 2 will be gradient.
Yes.
So you are going to pass through origin because there's no intercept. So it will pass through the origin. The graph is expected to pass through the origin because there's no intercept here. So having done that, so the next thing is just greatest go to G over 2. How do you calculate G? Just from multiply. So that's how to calculate the experiment, how to calculate value of G. So the next thing is the last one that this one is a projectile. It's a body that is under the influence of horizontal and vertical components. There are two types of projectile. The
Mm-hmm.
first one, it depends, tell you, you will know from the question. The question will say an object is projected at an angle to the horizontal. an angle to the horizontal. So that's case one. When it's projected at an angle to the horizontal. So you have this type. So you have all these. You have the diagram here. So let's explain what V. I use V here. They can also use U. So I'm using V here. Initial velocity, it can be U. Doesn't mean must be V. Vx means horizontal component and is given as V cos theta. Vy means vertical component, which is given as V sin theta. Then the horizontal range from here to here, that's the range. Now maximum height, that's the maximum height. So let us see the formula. How do we go about it? So time to reach the maximum height means that time to travel from here, from this point to this point.
Yes.
As if you travel up and down, that's time to reach the maximum height. And it's given as V, it can be U, it can be V, V sin theta over G. Time of flight means time to travel from here down to this place. Time to travel down from here to maximum height to this particular point, that's called the time of flight. And that's multiplied by 2. Multiply small one by 2. So this, that will give you this. Maximum height, because distance between this and the maximum height. So that's the way we put all this. So this is the range, horizontal range. Now, case 2. Case 2, we only have two formulae for that. Only two formulae, not more than that. When an object is projected from a height, you can see that there will be a certain height. You can say from a height, from the top of a building, from an electric pole. There must be something that represents height. That's what the person will tell you. There must be something that represents height. That's how
Yes.
to know. But under this, you have to formulate this. So you might need to use the two at the same time for you to get together to get the answer. For instance, you're looking for range now, and you're giving the question cell range. Okay, you are it. Okay, let me see. For instance, you have the height. You are giving height of 20 meters. You are giving this Vx as a 5 meter per second. So this question asking me to calculate range. So in this case, if you use the second formula, it's not done. You can't get it because you have V, you don't have T. So it is expected of you to first use the first formula to calculate T. So whatever you get for value of T, then return it here. So that's why I say you might need in fact, most time you will need the two formula together at the same time. So first of all, put the value of H here, value of G as 9.81, then get the time. So when you get the time, then multiply by velocity, that will give you the range. So these are the two formulae we have here under this type. The two formulae that we have under this type of this.
So may you please go over
Now,
it again?
to what is it?
So I was saying, may you please go over it again?
This, I said you have two formula under this type of projector. So
Mm.
the two formula needs to be, you have to use them. You might need to use this first one to get the value of what, if for instance you have to calculate range. They gave you
Yes.
velocity. They're not
Yes.
giving time. They also give you height. So you are giving height. So you know height and velocity. And
Yes.
no. And you're looking for range. So definitely you cannot use this. There's no single formula cannot take you to it. Because
Mm.
you have for you to calculate range, you need velocity and time.
Yes. So you're saying
Now
that I should use H to
you have
find the
to use
time. Then
first
I sort of,
that's what I'm saying. So use the first one to calculate the time. Then before we
yes.
now substitute the second one. So that's
Okay.
how it works. Okay.
Yes. Yes.
Now this modality is also called time of flight. It's also called time of flight. Okay, I think I'm going to put something like project. I don't think it's here. It's not here. Okay, I put it. Now, velocity at which an object is just about to hit the ground. That's what the question will tell you. Calculate the velocity at which an object is about to hit the ground.
Mm-hmm.
So this is the formula. You have to go and calculate vertical components, horizontal components, before calculate vertical component, calculate horizontal component, then before you now apply the formula. So what's the direction to the horizontal? V this over this. I will use this thing now. Do this particular aspect. Familiar after this. Go and work on this. We have what I was saying then now is that at maximum height, the vertical component of velocity is zero, but the horizontal component is not zero. So take note of that. Now, if you are to, the question say calculate the velocity. So therefore, the velocity at maximum height is the same thing as what? Horizontal component. That's all. So the question just say calculate velocity at maximum height. What do you what are they asking to do? They're asking to calculate what? Horizontal component.
It's
Why?
a
Because
horizontal.
because there is no vertical component. There's no
Yes.
vertical component. So
Yes.
that's that. Another projectile. Let me explain one thing more, but let me use a blank page to write. You might be asked to calculate displacement. For instance, you have a projectile like this. Yeah. So this is type now. Now, the question may ask you to calculate the displacement travel by the object. So for instance, you can label as point A. What is displacement travel? How do you do it? So displacement travel, they ask you first of all draw a straight line.
Displacement would.
Yeah. So this line AB is the displacement.
Yes, sir.
Displacement. So that means what do? You know the height. So you have to calculate what? Range.
Range.
And calculate range. Use Pythagoras theorem.
Pythagoras.
Is it
Yes,
clear?
sir. Yes, sir.
That's this type. In the first type two, the first one, when is this type? It can be like this. And okay, on this type, the question says calculate the displacement travel at whatever. You can say at point A. Calculate displacement travel at point A by this projectile. What do? Draw a straight line, then draw it down. This is the maximum height. So you are looking for this is going to give a range over 2, half of the range. So what do? Go and look for maximum height. That is, look for maximum height. Look for I can say this A. You can call displacement D. That's a D displacement. So what do? First of all, look for what height. Get
Yes.
let me just say get the maximum height, get the range and divide it by 2. So the step here, get maximum height. The next step,
Get the
get
range.
range, divide
By two.
range by 2. Last way, use what? Pythagoras theorem. So your Pythagoras theorem will now give you square root of the range over 2,
Plus.
then maximum height. So that's displacement. Is it understood?
Yes, sir.
Okay. So you can quickly just so that will be displacement. So let me see the deformed solid. Deformed solid before we okay. Deformed solid. Deformed solid. Fine. Compressive and tensile forces. When you have a wire, if you have a wire, you bend a wire that is being bent in this form. You have this particular, let's say this is a wire. Then if it bend, it's going to be this. Don't mind my draw. Oh, I didn't draw it very well. So it's going to be this like this. So if it's like this, the upper part here undergo more stress more than the lower parts. More than the lower part here. So this is what we refer to as tensile stress. Now, if you
When you
have
say which part
this,
undergoes lesser,
this one, this one is higher. The lower
but
part is this one is lower. This one is lower. This one is higher. Higher stressed. Higher stressed. So this one's lower. Now, if you have a thick, let's say thick, this rod, yes, let's say thick wood, and something, and the one that is not thick like that, and the one that is thick or thicker, that one will bend. That one can break easily when you are trying to
yes,
bend in this form. When you are trying to bend it, but the one that is very soft, that one can bend a long way before what? Before it can be broken.
break,
So that
yes,
means the one that can break easily means is undergoing higher, there will be a what you call higher stress there. That is why it's able to break easily. But the one that can take longer
yeah,
time, meaning that it's lesser compared to the one that can break easily. So the thicker wire break with less bending. Yeah. So at time before you bend it for long, that break. So next thing, the Hooke's law says force is proportional to extension and compression, or provided elastic limit is not exceeded. But you put it to, but most, in fact, chemists said they might not even hammer that point. Their major point is force is proportional to extension.
okay,
Apply force, square cranes, and the elastic case also called stiffness. Fine. So let's now look at this particular graph, the behavior in this particular graph. So we have what is called elastic region. We have what is called plastic region. If we have an elastic material, if you keep on stressing the material for long, you discover that it becomes inelastic. So it will now return to its normal length. So it becomes inelastic. It will now return to its normal length. So after some time, it has lost its elasticity. So at that point, it is now a plastic region. So any little effort that you apply, so the material is liable to break. It will break. So if you get to a breaking point, it will break. Now, what's the difference from zero to A? We call it limit of proportionality. From limit of elasticity, that's the difference between them. What's the difference between A? At A means from 0 to A means that if you stress a particular, let me put it this way. If you
like
have,
if you
let's say,
remove to return to
uh,
its origin,
thank you. If you remove the load, it will turn back to its normal one. So that was happening
yes,
from 0 to A. Another thing, Hooke's law is obeyed. This is proportional to A.
mm-hmm.
That's all. But when you now if you get to point B here, if you get to point B, Hooke's law is not obeyed, but material will still return to its normal length by time. So that was happening here. That's called elastically. Material will return to its normal length, but F, but
Not
at that F is not proportional to X. It is not proportional. Do you get the difference
yes,
now? Okay. So that's the
yes,
difference. It's not proportional. So that's different. So anything now beyond that, you have left the elastic region. So you are going into plastic region whereby it's not going to return at all. From here to here now, B to this, the material does not return at all. So anything, it has been deformed. So that's what we have here. I think this is what I explained here. Just the plastic region is really, you get the limit of polarity beyond which is most external. So that's what I just explained here, the note here. After the yield point, the material enters plastic. Fine. Deformation, which means the stress of the wire is permanent. For example, the wire is stretched to point C. They are just the okay. I better put some things here. I want to readjust these notes. So I'm not having time on this topic. I want to start another. I want to form another one, but I want to readjust one, but not now. Still okay. Now, these are there are some points that you need to note here. Definition. What is elastic deformation? What I mean by plastic deformation? What I mean by elastic limit? They are just definition that you need to know. So they are just definition. Now, there's something called arrangement. We arrange spring like under resistor, series arrangement, parallel arrangement, under capacitor. We do that under string, under spring. So that's what we need to do now. Deformation, series arrangement. How do you arrange? When we arrange, how do we get? We use something parallel. So let's say arrangement of this. If I have the identical spring, identical spring means they have the same spring constant. So you have 1, 2, 3. They have the same value of K, identical spring. And you have load being attached. Fine. This is 3. So how do I calculate total spring constant? You use parallel 1 over K total. That's 1 over K plus 1 over K plus 1 over K. So do the SCM, which is K. This will give you 3. So 1 over K total here. That will 3 over K. So K total, that will give you K over 3. Do you get it?
Yes, sir.
Okay. Now, if you have to now calculate extension total now, just do it this way. What was the inverse? This one mean 1 over 3K. What was the
Yes.
inverse of 1 over 3?
3.
3. So that means 3x. Just change it to x. Period. So once you calculate K total, to calculate x total is very simple. So when you determine K total, just find the inverse, then change it to x.
Yes,
So
sir.
assuming K total is giving you 2 over 5K, what do you think is going to be x total? What should be x total?
5 over 2.
5 over 2 what?
X.
2 over 2 and 5 over 2x. So that's all. So that's going to be, so once you calculate that, that will be very simple. You see now. Now, the parallel one is easier to do, which is just like, so we can now combine, okay, I'll give you,
Load we divide equally shared.
so the parallel one is easier to do, just add up. So when they are parallel like this, just add up. So you have K, K. So K total will give you K plus K. That was 2K. What's the inverse of 2?
1 over 2.
1 over 2x. That will be x total.
Yes, sir.
Okay, fine. So we can combine different one. I will do that, but let me first of all move on so that because our time is we have people, so that I can able to finish this thing. I will come back when if I'm done earlier, I will come back to I can combine them together. But let
Okay.
me quickly move on. Yeah. So that what we have here, spring constant. So okay, we have stress how to do you must able to define them. So simple definition. You can write the formula, it's okay. So
Yes, sir.
either you can write the formula, it's okay. Oh, this is even wrong, self. It should be per meter square minus 2. Then put minus because this is in a program. I use latex to type this thing. It's a code. So modulus, the same thing, force per unit area. You can get a formula follow like this. If you say stress
Yes.
over area, so it's going to give you this. Fine. Now it has experiment. The experiment is divided into 3 aspects. It depends on what the person is asking you to do. Maybe the person asking you the first aspect or second aspect or the last, or they just say this if the question is asking you describe the experiment, that means you have to go through all the three aspects. You have to go through all the three aspects. But the question is, so experiment determinant of your module. Number one, description of the apparatus with the head of diagram. So it's compulsory. If the question say description of the apparatus with head of diagram, so you have to draw this and explain the two things on it. So you must be able to sketch this. Even that's all they want to require from you, in terms of description of the apparatus. That's what they want to explain. So you have the apparatus this way, you have vernier scale, you have the mass angle, you have the weight, you have the controlling wire, you have the main scale. Under vernier scale, vernier caliper is divided into two. We have main scale and vernier scale. So vernier caliper measures the diameter of the wire. Fine. Now, description of the apparatus. Two identical wires P and Q are suspended from a support here, that is suspended like this, anchored like this. Fine. What next? The wire P carries the main scale and the weight is on. Yeah, that's what I explained. This is a main scale, a weight is attached. So the next thing is a standard masses are added to the wire Q to measure the increase in length. So as you are adding standard masses, maybe 5 kg, 10 kg, you're adding it here. Here. This is a mass hanger. You put one mass, so what happens? It will be extending. You want to know. First of all, this is how it works. First of all, you take the reading here on the vernier scale. Maybe it's about, let's say, 2.4 millimeter. I don't know. Let's say the length. So by the time you had mass, you take another reading. It will increase. The reading will increase. Maybe now 2.82 millimeter. So what's the extension now? The difference between the readings. Are we together?
Yes, sir.
Okay. So that will give you extension between that. So that's that. So, and that's all. So you
Yes.
have to scale 1, 2, 3. These are the three statements required of you. If you have to describe the apparatus,
Yes.
description of the apparatus, that's all. So three things expected. They are expected from you to state. So 2, describe the method used to obtain the required measurement. So the question may say, describe the method used to explain when it comes in elasticity, you determine the modulus. So that means they always work. Or in fact, the question I've seen when they distribute the question in three forms. Question I1, describe apparatus, I2, method, I3, how the method could be used. So they want the three together. So what was the method? Measure the original length of the wire using the meter iron. Measure the diameter at a different point, micrometer screw gauge, at different places along the wire. So what do you do to calculate the average? So this is the wire. Take the diameter, maybe at this point, at another point, at another point, find the average. So the weight of the wire is increased, so, and the extension is obtained by subtracting the vernier caliper and this. Like I said the last time here, whatever reading when you add this or this, so subtract the two, that will give you the extension. So what happens? So the next thing, remove the load. What's the purpose of? I've seen a question. Say, explain why the purpose of removing the load here? Why? To help us check the elasticity, whether if the material returns to original length. So we want to check whether we have not gone beyond elastic region. So to check the elasticity of the wire, that's the purpose of removing the wire, the load. Did you get it?
Yes, sir.
Okay.
Yes, sir.
Okay. The
So
third
in the
one.
next lesson, may you please explain how vernier calipers and a micrometer screw gauge works? Like in the next lesson, not this one.
How to calculate? It's no longer in syllabus.
Like measurements. Yes, sir.
It's no longer in syllabus. It's not in syllabus again.
Say, but like for practical, we needed say like one time they gave us
Vernier
micrometer.
caliper.
Yes, sir.
Okay. And then, maybe when we're about to write exams, we do that. We need to put it. But in the normal theory, it's no longer syllabus. They remove it from syllabus.
Yes.
Description of the methods could be used to determine. So how do you determine your modular area? Area means pi square pi this over 4. So when you done the rad is done, so what's the next thing? Calculate you measure the diameter, of course, put the diameter there, calculate the extension already, then now plot a graph of force against x. So if you are plotting a graph of force against x from this particular formula here, this is
Can be
your modulus is that force over area
yes,
over extent over length. Do the mathematics. It's going to have you. It's going to have
because
f
and over
times n power x, and that's what I have here.
it.
So if you now have this, so if you do this now, if you have this times, you are going to have that f over x like this. Then I'm going to have what L over A. What's f over x? Spring constant. That is k. So that will give you k. Then I have L over A. So that's all. So if you now remember, k is a gradient of from f, a graph of f against x. This is a gradient. K is a gradient. So that's a gradient is equal to original length times this area. So from here you calculate the detail, determine the value of this, the experiment. Put the value of diameter. When you plot the graph, go and look for gradient. Oh, it's here. Update the gradient. Fine. Look for gradient. You measure the length already with meter rule. Put the diameter, then calculate. Use your calculator. Everything is fine. Strain energy of elastic potential energy. Anyone. This is the formula, please. This is the definition, please. It's the ability to do work as a result of change of shape of an object. As simple as that. Maybe 2 marks or 1 mark. So ability to do work in it as a result of change of shape of an object. That is called elastic potential energy or strain energy. So when you have this kind of graph, force against distance, note the strain energy is equal to area under force against, yeah. Area will give you, look at it now, this is area of triangle. So if this is area of triangle, if this is area of triangle, so area of triangle mean base times I divided by 2. That's fx over 2. Now
Yes,
note, now the first must be here. That particular for when you have this, it must be named. This also must be meter. Always check that. Must be anything else or must be meter. So if if that is fine. Now another thing that the to be elastically extended means that the material returns to, because what you explain the meaning of what does elastic extended elastically mean, or to be elastically extended means? It means that it has not gone beyond elasticity. That is the load, the return to original length after the applied force. Now take note, when you have f against x, so in this law, gradient k is a gradient. But if you now have it like this, x against f. So in this case, k, this one, k is 1 over gradient.
yes,
So this one is applicable to this graph. So take notes. It's applicable to this graph.